Before the first alarm, the ocean is doing its best impression of peace, a black mirror, calm enough to make you trust it. The problem is that trust is exactly what swarms exploit. Low flyers live inside the seam between sky and sea, where radar has to argue with clutter and the horizon eats your line of sight. On the bridge, the night watch keeps its voice flat on purpose, because emotion spreads fast, and calm is a kind of armor. In CIC, it starts as tiny friction, a pause that lasts half a second too long, a cursor that stops moving, a headset that gets adjusted twice. Then one contact becomes two becomes a spray of returns, and suddenly the tactical picture stops being a map and turns into a clock that is running louder than the speakers. A swarm is not just objects in the air. It is an engineered shortage of seconds, built to make you choose under pressure, and choose wrong. This is Battletech Declassified. Modern warfare explained. In a fair fight, you trade strength for strength, but swarms are not built for fairness. They are built to force spending. If you treat every blip like a missile you must shoot, you start buying safety with your most expensive currency, hard kill inventory. One early shot becomes 10 becomes empty cells, and the attack has not even revealed its real teeth yet. That is why real doctrine does not start with destruction. It starts with control. You are not trying to erase every drone. You are trying to break the attack's shape, to make timing collapse, to make formation scatter, to make the wave arrive as isolated leftovers instead of a synchronized hammer. This episode is about the weapons and tactics that create that collapse on purpose. Soft kill first, hard kill last, and offense layered upstream so the swarm is smaller before it ever reaches the ship. Future weapons are usually sold like a superhero scene. One beam, one click, problem solved, and the crowd applauds because it feels clean. But swarms are designed to be dirty. They hide inside clutter. They split into layers. They throw decoys first, and they dare you to waste your best ammunition on the cheapest objects in the sky. That is why the biggest lie in swarm defense is the idea that you can simply shoot your way out, because shooting scales poorly. If the enemy doubles the number of drones, you do not need double the missiles. You need double the time, double the attention, double the confident track quality, and those things do not double just because you wish harder. The real playbook flips the marketing order. Soft kill first, hard kill last. Not because soft kill is gentle, but because it attacks the swarm's nervous system, the parts that must coordinate for the attack to arrive as a single synchronized wave. If you can bend that nervous system, jam it, deceive it, confuse it, you turn one big problem into many smaller problems that arrive late and separated. Then hard kill becomes a broom, not a flood, a finisher, not a panic button. And the third piece, the part people forget, is layered offense. Because the best way to survive a swarm is to make sure fewer drones ever reach the waterline in the first place. Before you talk about lasers and interceptors, you need to understand the real battlefield, the invisible one. A swarm is a timing machine. It wants your radar to hesitate, your operators to argue, your fire control to chase ghosts, and your command team to spend their minutes on questions that do not matter. That means the first weapon is not a gun. It's the picture, the fused truth your ship believes. If that picture is polluted, if the tracks are weak, if the system cannot separate a decoy from a real threat, then every later choice becomes expensive and slow. Swarm warfare starts as information warfare, and the kills are just the last sentence of a story that began in the spectrum. So the doctrine begins with building a truth factory. Radar, EO, IR, passive RF sensing, offboard feeds from aircraft, drones, satellites, even other ships, all fused fast enough to matter. You do not need perfect awareness. You need early confidence, because confidence lets you choose soft kill precisely instead of spraying noise everywhere. This is where future weapons often look boring. Software, fusion, correlation, track hygiene, operator training to recognize deception patterns. It is the difference between swinging in the dark and turning on a flashlight that also tells you which shadows are lies. Soft kill is the art of making the swarm's plan fall apart without spending your hard inventory. The simplest version is jamming, flooding the control link with noise, but the modern version is subtler. It includes spoofing navigation, bending timing, feeding false bearings, and manipulating the drone's logic so it makes the wrong choice while believing it is making the right one. In practical terms, you are not trying to stop the drone. You are trying to break the swarm. You want drones to drift out of formation, to reacquire targets, to circle, to hesitate, to waste their own battery and their own seconds, because every extra second is a gift to your defenses. There is a reason navies prefer soft kill early. Early is when the swarm is still coherent, still synchronized, still dependent on shared timing. A small disruption early becomes a big miss later, like nudging a shopping cart at the start of an aisle so it hits every shelf down the line. Late soft kill still helps, but it is like trying to untie a knot while someone is pulling it tight. Early soft kill buys separation, and separation turns saturation into something manageable, because defense is not about being perfect. It is about shaping the flow of contacts into sizes your ship can actually process. Electronic warfare is often described like a single button, jam, but in reality, it is closer to chess at the speed of lightning. You have to listen, classify, decide, transmit, and adapt, while the enemy is frequency hopping, using directional antennas, and building autonomy modes that keep flying even when the link dies. If you jam too broadly, you blind yourself and you reveal your position. If you jam too narrowly, you waste power on the wrong band while the real swarm slips through another. The most valuable EW is targeted and timed, the right waveform, in the right sector, at the right second. To break the enemy's coordination instead of just making the sky loud is less than #0. 2# is greater than. In swarm defense, the goal of EW is often not disconnect everything. It is stretch the attack. You want the swarm to arrive unsynchronized, like a crowd forced to enter through a narrow door one by one instead of rushing all at once. When you stretch the window, you reduce the peak load on your sensors and shooters. And here is the unglamorous truth. EW has real limits: power output, cooling, antenna placement, line of sight, the risk of jamming your own systems, the legal and tactical rules of using certain effects near civilian traffic. That is why the best fleets treat EW as a managed resource, not a constant scream. And they pair it with deception and decoys to make the enemy's confusion expensive. Deception is the soft kill that feels like stage magic because it changes what the enemy believes without leaving a burning wreck. A modern ship can deploy decoys that mimic radar reflections, infrared heat, even the movement cues a seeker expects. The goal is to make a drone commit to a wrong aim point, a ghost ship, a hotspot, a false track, a bright lie that pulls it away from the real hull. In a swarm, deception is multiplied because every drone that chases the wrong thing is one less decision you must make, one less object demanding a missile, one less chance for a lucky hit. But deception also has trade-offs. Multi-sensor seekers can compare radar and IR, and some drones can share observations, voting on what looks real. Weather affects IR, sea state affects clutter, and decoys can be exhausted if you deploy too many too fast. That is why decoys are most powerful when combined with silence and movement, reducing your own signature, changing heading, masking behind clutter, using the environment like cover. The trick is not just to throw a fake. The trick is to make the fake more believable than you for long enough that the swarm breaks into wrong guesses and late arrivals. A lot of people think cyber in warfare means hacking a laptop in a dark room, but in swarm defense, cyber can be physical and immediate. It can mean exploiting the protocols the drones depend on, the update channels, the common hardware, the shared GPS timing, the data link standards. The dream effect is not take control of every drone. That is rare and hard. The dream effect is simpler. Make the swarm unreliable. Make it misreport. Make it mistime. Make it disagree with itself. If you can poison the data the swarm uses to coordinate, you do not need to win a wrestling match with each drone. You just need to make the swarm's group chat collapse into chaos. The limitation is that cyber is not a universal key. You need intelligence, access, preparation, and sometimes proximity. You need to know what you are targeting, and the enemy can harden systems, isolate networks, and build autonomy that ignores external inputs. That is why cyber is part of layer defense more than last-second defense. It is something you plan, something you seed, something you use to reduce the size and quality of the attack before it ever reaches the ship. When it works, it looks like nothing. No explosion, no flash, just an enemy strike package that shows up late, scattered, and strangely confused. And confusion is a form of protection. Autonomy changes the rules because it reduces the swarm's dependence on a live link, and that means some classic soft kill tricks become less effective. A drone that can navigate by inertial systems, match terrain, or use onboard vision does not panic when GPS is jammed. A drone that has pre-planned waypoints can keep flying even if the data link dies. So the future of soft kill is not only blocking signals, it is shaping behavior, nudging the drone's internal decision logic into the wrong branch. You do that by manipulating what it senses, cluttering the scene, creating false features, confusing classifiers, and forcing the autonomy to waste time verifying what it thinks it sees. This is where counter-swarm becomes a contest of algorithms and environments. Heat haze, clouds, reflections, sea spray, city lights. All of these can be used as cover or as confusion. But there are trade-offs, because some deception techniques can also confuse your own sensors, and some effects are hard to control at sea. The practical approach is layered soft kill, different effects aimed at different guidance types. Some for RF links, some for GPS reliance, some for optical seekers, some for the coordination layer between drones. You are building a maze, not a wall. And the maze is designed to make the swarm spend its energy solving problems instead of hitting steel. Hard kill is the part everybody understands because it is visible. Missiles launch, guns fire, drones explode. But in a swarm, hard kill is also where you can lose the war in 10 minutes because your inventory is finite and your firing timeline is cramped. Every hard kill shot is a choice, and choices cost attention. Even if you had infinite missiles, you do not have infinite engagement windows, and you do not have infinite radar tracks you can maintain with high quality under jamming and clutter. That is why hard kill must be the last layer, the finisher, used when the swarm has already been weakened, separated, and slowed by soft kill. The harsh math is simple. Missiles are expensive, reloads are slow, and you cannot reload VLS cells like magazines in a video game. Guns are cheaper per shot but limited by range, line of sight, and the time required to put enough rounds on target. Close-in weapon systems can shred a single incoming object, but a dense wave can force them into target switching and dead time. The practical doctrine is to reserve hard kill for the contacts that remain credible after soft kill, and to prioritize the ones that threaten mission kill. Sensors, flight deck, bridge, key radars. Because in a swarm, the enemy often aims to blind you first, then hit you. Lasers are the poster child of future weapons, and they are real, but they are not magic. A laser is not a lightsaber. It is a heat delivery tool that must stay on a spot long enough to cause failure. That means dwell time matters, atmospheric conditions matter, stabilization matters, and power and cooling matter. Sea spray, haze, rain, and turbulence can reduce effective range, and a drone that spins, maneuvers, or uses reflective coatings can increase your dwell time requirement. In a swarm, dwell time is your enemy because the sky is full of targets, and your laser can only cook one place at a time. So how do militaries actually use lasers against swarms? As a complement, not a replacement. Lasers are great for the cheap end, the small drones, the ones you do not want to spend a missile on, especially when they arrive one by one after soft kill has broken the wave. Lasers can also be used to blind sensors, burn apertures, and force a drone into a fail-safe mode. The limitation is that lasers need conditions and power, and they can be saturated by numbers. That is why the real laser story is integration. Laser plus EW plus decoys plus guns. Not laser solves swarms, but laser saves missiles when the rest of the stack has done its job. Guns are the old answer, but in swarm defense they become new again when paired with smarter fusing and better fire control. A proximity-fused round that bursts near a small drone can turn one shot into a cloud of fragments. A guided or course-correcting round can reduce wasted ammunition. And modern radars and electro-optical trackers can hand off targets faster, reducing the dead time between engagements. This matters because swarms punish dead time. They want your system to finish one target and spend precious seconds reacquiring the next while the wave keeps moving. The limits are still real. Guns need line of sight. They are affected by sea clutter near the horizon, and they must respect safety arcs, friendly aircraft, and the reality that a miss does not vanish. It keeps flying. Guns also struggle when targets approach from many bearings at once because traverse and engagement sequencing become bottlenecks. That is why navies pair gun layers with soft kill that shapes approach angles, sectors, and timing, and with decoys that pull some drones away from the ship's protected arcs. Guns are not the hero. They are the bouncer at the door, effective when the crowd arrives in smaller groups, dangerous when the crowd arrives as a stampede. Interceptors are the most reliable hard kill, but they are also the easiest to bankrupt. If you shoot $1 million missile at a $10,000 drone, you can win the battle and lose the campaign because the enemy can afford to try again tomorrow. That is why future interceptors are moving in two directions at once: higher performance for the truly dangerous threats and lower cost options for the mass. Some navies pursue smaller missiles, smaller seekers, faster reload concepts, and smarter engagement logic to avoid overkill. The goal is not to have the biggest punch. It is to have a sustainable punch count. But even cheaper interceptors do not fix the saturation problem alone. You still have launch constraints, track constraints, and engagement management constraints. You still have the problem of decoys pulling missiles off, and the problem of jamming degrading seeker performance. That is why interceptors are paired with soft kill that reduces the number of credible targets, and with layered defense that reduces the number of drones launched in the first place. The uncomfortable truth is that hard kill will always be the last resort in a true swarm scenario, because if you rely on it as your first resort, you are agreeing to play the enemy's economic game. Layered offense is the part that turns defense into strategy, because it asks a different question. Instead of how do I stop every drone, it asks why are there so many drones in the air at once? The swarm has a supply chain, launch sites, storage, operators, data links, relay nodes, sensors, and timing references. If you can break any of those upstream pieces, you reduce the wave before it exists. That can mean striking the launchers, hunting the command vans, jamming the relay aircraft, sabotaging the navigation references, or using your own drones to attack their drones on the ground. You are not just catching arrows. You are looking for the archer. This is also where future weapons show up as systems, not gadgets. Long-range ISR to find staging areas, loitering munitions to hold targets at risk, anti-radiation weapons to punish emitters, cyber and EW campaigns to degrade coordination days before a fight. And it is not always kinetic. Sometimes, layered defense is political, shaping the environment so the enemy cannot position launch assets close enough or cannot rehearse without being watched. The limitation is that offense requires intelligence and access, and in some scenarios, rules of engagement or geography will constrain what you can hit. That is why layered offense is paired with layered defense. You reduce the wave, then you disrupt it, then you finish what remains. One of the most practical offensive tools against swarms is counter-reconnaissance, because swarms need information to be effective. They need target location, target motion, and sometimes target identification. If you can blind the enemy's scouts, you can force the swarm to search, and searching burns time and battery. That means shooting down their ISR drones, jamming their maritime patrol feeds, deceiving their satellite cues, and denying them clean targeting updates. In simple terms, you make the enemy swing at where you used to be, not where you are. This creates a loop that favors the defender. The enemy spends more drones to find you, more time to confirm you, and more effort to coordinate, and all of that increases friction. The trade-off is that denial is not perfect, and sometimes you must admit to defend yourself, which can reveal your presence. So, modern doctrine aims for controlled emissions, short bursts, directional effects, and using off-board sensors so the ship itself stays quiet. The future weapon here is discipline, the ability to fight while revealing as little as possible. Because in a swarm war, your signature is a beacon, and offense often starts with refusing to be an easy target. Put all of this together, and you get the real counter-swarm stack. Not a single wonder weapon, but a layered rhythm. First, build confidence in the picture. Fuse sensors. Detect poisoning. Keep track quality high. Second, apply soft kill early. Jam links, spoof timing, deploy deception, break coherence. Third, shape the flow with movement and emissions discipline so the wave arrives late and separated. Fourth, reserve hard kill for what remains credible and dangerous, prioritizing mission kill threats and protecting the sensors that keep your truth factory alive. And above all, run layered offense to reduce the wave before it exists, because the best defense is fewer drones in the sky. The reason this works is not because it is glamorous, but because it respects constraints: power, cooling, line of sight, inventory, rules of engagement, operator cognition, all the limits that brochures hide. Militaries fight swarms by managing those limits, by forcing the enemy to spend more time and more uncertainty for every meter they advance. That is the real future weapon, not one device, but a doctrine that makes the swarm fail in stages. And in the next segments, we are going deeper into how that doctrine looks when the enemy adds decoys, mixed seekers, and surprise angles, and when the ocean itself becomes part of the fight. The swarm gets more dangerous the moment it stops being one kind of thing. The first wave might be cheap quadcopters skimming low, the kind your brain wants to dismiss. Then right behind them come faster loitering munitions. Then higher up there's a relay drone acting like a floating cell tower, and somewhere in that stack is the real striker you were supposed to notice first. Mixed layers are not about more firepower. They are about more confusion, because each layer demands a different sensor, a different timeline, and a different weapon. If you answer everything with the same response, you are playing the enemy's game, because the enemy designed the layers to make your response feel wrong no matter what you pick. The practical doctrine is to triage by purpose, not by shape. Which contacts are scouts, which are decoys, which are shooters, which are relays, which are bait meant to make you light up your radar. Soft kill becomes your first sorting tool because it can reveal behavior. A decoy does not react like a real seeker. A relay behaves like a coordinator. A true striker tends to hold a cleaner line, protect its geometry, conserve its energy for the final run. When you treat the sky like a story instead of a screenshot, you stop panicking at blips and start hunting rolls, and that is when your limited hard kill starts landing on the few targets that actually matter. Decoys are the swarm's favorite insurance policy because they cost less than your reaction. A drone can carry corner reflectors, heat sources, or simple emitters that light up your sensors like a fake Christmas tree. Some decoys are not even drones. They are floating reflectors, chaff clouds, or burn pots that create an infrared distraction at exactly the wrong moment. The goal is not to trick you forever. It is to trick you for 30 seconds, just long enough to make you fire early. Just long enough to split your attention. Just long enough to force your systems into target switching. In a saturation fight, target switching is where seconds go to die. That is why the counter is not just better sensors, it is better discipline. You do not spend hard kill to clean the screen. You spend hard kill to protect the ship's ability to see and decide. Soft kill first means you use EW and deception to degrade the decoys and expose the real threats. You can also use your environment, change heading, change speed, change emission posture, force the seeker to reveal itself by making it work harder. The moment the enemy has to work harder, it emits more, it searches longer, it becomes more identifiable. And identification is what turns a confusing swarm into a manageable queue of priorities. One of the quiet revolutions in counter-swarm warfare is the rise of dazzlers, not lasers that burn, but lasers that blind. A drone is often a camera with a brain, and if you ruin its vision, you ruin its aim. Dazzlers can overwhelm optical sensors, wash out contrast, and break the drone's ability to lock onto a target. It is soft kill that looks like nothing from far away. No explosion, no smoke, just a drone that suddenly starts drifting, wobbling, or hunting like it lost its confidence. In the right moment, that is as good as a kill. because a confused drone becomes late. And late is survivable. The trade-offs are real. Atmosphere matters, haze and spray scatter light, and drones can add filters, shutters, or different spectral bands to reduce the effect. Dazzlers also demand precise pointing and stabilization, and your ship is never perfectly still. That is why they are part of the stack, not the whole stack. You use them to force seeker failure, to create separation, to degrade the smart drones so the cheap ones are no longer protected by the advanced ones. It is like blinding the coach on the sideline. The team might still run, but their coordination collapses, and that is exactly the failure you want. High-power microwave is the other directed energy story, the one that sounds less cinematic but can be more swarm-friendly. Instead of heating a single spot, you are trying to overwhelm electronics across a wider area, a burst that can reset circuits, crash guidance, or force a drone into a failsafe. Think of it like a flashbang for machines, not guaranteed destruction, but guaranteed disruption. In a swarm, disruption scales. If you can cause even a fraction of drones to glitch at the same moment, you create spacing, you create collisions, you create hesitation, and hesitation is a weapon that buys your guns and missiles time. But microwaves are not a magic broom either. Range is limited, aiming matters, shielding matters, and the effect can be unpredictable across different drone designs. You also have safety and interference concerns. You do not want to fry your own systems or friendly sensors. That means the best use case is controlled, sector-based, tied into your truth factory, so you fire at the right moment in the right lane. In the stack, microwaves are a soft kill multiplier, a way to create chaos inside the densest part of the wave, so the wave stops behaving like a synchronized hammer and starts behaving like loose debris. The ocean itself is a weapon, not because it fights for you, but because it lies. Sea clutter can hide low flyers. Reflections can create phantom tracks. Waves can mask a fast skimmer until it is suddenly close enough that your engagement window is measured in breaths. In those moments, the fight is not about technology. It is about time. Your ship is trying to compress detection, classification, decision, and action into a few seconds, while the enemy is trying to stretch and poison every one of those steps. A swarm that stays low is not just hiding, it is forcing your systems into their hardest geometry. That is why real counter-swarm doctrine is obsessed with angle management. Ships positioned to maximize sensor coverage, to reduce blind arcs, to keep the most capable radars facing the most likely approach lanes. They coordinate with other ships, aircraft, and drones to look over the horizon, because your own mast height is a physics limit you cannot negotiate with. Off-board sensors are not a luxury. They are a way to start the clock earlier. And starting earlier is the difference between soft kill being a gentle nudge that breaks coherence and soft kill being a desperate shove that arrives too late. Cooperative defense is the future weapon that does not look like a weapon at all. It is the idea that your ship should not fight alone. A single ship has a limited horizon and limited channels, but a group can share tracks, share sensor angles, and share engagement responsibilities. One platform sees, another shoots, a third provides EW, and a fourth stays quiet to preserve a clean picture. When done well, the swarm does not face one defender. It faces a network, and networks are harder to saturate because they can reroute attention the way traffic reroutes around a blockage. The weakness is that networks can be attacked too. Links can be jammed, data can be delayed, false tracks can be injected, and coordination can become a burden if it turns into bureaucracy. That is why trust first matters. You build redundancy, you validate tracks, you train procedures so the group can act without a committee meeting. The best cooperative defense feels simple to the operator, because the complexity is hidden in automation and rehearsed doctrine. In a swarm fight, simplicity is not laziness, it is survival, because you cannot outthink chaos if your process is slower than the incoming wave. Now the hardest truth. Some swarms will get through, and the enemy knows that. They are not always trying to sink the ship, they are trying to mission kill it. Blinding a key radar, damaging a flight deck, knocking out a comm mast, breaking the systems that make your truth factory work. That is why hard kill prioritization is not about what looks scary. It is about what threatens the ship's ability to see and respond. A small drone with an explosive charge aimed at a radar face can be more dangerous than a bigger drone aimed at a random piece of steel. This changes how you spend your last layer. You do not defend the whole ship equally. You defend the brain and the eyes first, because if the brain survives, the body can still fight. Point defense and rapid-fire systems become guardians of specific zones, and damage control becomes part of the counter-swarm stack. The future weapon here is resilience, redundancy in sensors, spare pathways, protected apertures, quick repair protocols. It is not glamorous, but it is the difference between taking a hit and becoming blind. And if a swarm can blind you, it can keep hitting you until you run out of options. A swarm also attacks your mind, not just your hull. The watch team is a finite resource. Attention is a magazine that empties with every decision. The enemy knows that if they can force you into constant alerts, constant false positives, constant switching, your crew becomes slower and more error-prone, and then even perfect weapons feel imperfect. That is why modern doctrine treats operator workload like a battlefield variable. Automation is used to reduce noise, to rank threats, to recommend actions, but the human still owns the final moral and tactical choices, and those choices must be made under pressure without freezing. The trade-off is trust. If automation is wrong, it can burn your inventory faster than panic can. That is why trust first means you build systems that explain themselves, that show confidence levels, that reveal when the picture is uncertain. The best future weapon is not an AI that shouts an answer. It is an AI that protects your team's tempo, filtering the chaos without hiding the risk. In a swarm fight, tempo is everything. If you keep tempo, you keep control. If you lose tempo, you start reacting, and reacting is where the swarm wins. Some of the most effective offensive layers against swarms are cheap and unmanned. Your own drones, not as targets, but as hunters. If the enemy launches from coastal sites, trucks, small boats, or hidden pads, your best defense might be to keep persistent eyes on those areas and hold them at risk. A small loitering munition waiting quietly can destroy a launcher in seconds. A scouting drone can spot a staging area before the swarm is airborne. This is layered offense in its most practical form, reducing the wave by hitting the source, not the arrow. But offensive drones also have limits. They can be jammed, shot, or spoofed. They need basing. They need logistics. They need secure comms. That is why the doctrine is layered. You do not bet on one platform. You combine persistent ISR, cyber preparation, EW pressure, and kinetic options, so if one pathway fails, another still holds the enemy's launch chain under threat. The goal is not to stop every launch forever. It is to force the enemy to take longer, to move more, to emit more, and every extra action gives you more chances to detect and disrupt before the wave forms. A lot of people miss the importance of geography in swarm warfare. Narrow seas, island chains, coastal clutter, and shipping lanes create hiding places and constraints for both sides. A swarm launched from close range compresses your timeline. A swarm launched from behind land masks itself until late. That is why the best counter-swarm planning begins long before the fight, choosing routes, choosing operating areas, choosing formations that reduce surprise angles and maximize your ability to see over the horizon. Future weapons do not override bad geometry. They just make bad geometry slightly less hopeless. So doctrine tries to avoid the perfect ambush. It uses standoff distance, picket assets, and layered sensors to extend the warning line. It treats choke points like danger zones, where the enemy can hide launchers and where your ability to maneuver is limited. And it builds deception into movement. Sometimes the safest posture is not silence. It is controlled noise that makes the enemy waste their best shot on your worst position. The future weapon is not just what you carry, it is where you choose to be. Because in a swarm fight, position decides how many seconds you are allowed to have. Let's talk about the myth of the single shield. People love the idea of one system that protects everything, a dome that makes you invulnerable. But swarms are built to poke holes, to find seams between layers, to arrive from multiple bearings, altitudes, and speeds. The defense is therefore a mosaic, overlapping arcs, overlapping sensors, overlapping effects. The goal is not perfection. The goal is that no single failure becomes catastrophic. If one radar is degraded, another still sees enough. If one soft kill effect fails, another still creates friction. If one hard kill lane is saturated, another still catches the leftovers. This is why layered is not a buzzword. It is a survival habit. You build layers by different physics: RF, optical, thermal, kinetic. You do not stack the same type of solution and call it depth. And you build layers by timeline: early soft kill upstream, mid-course disruption, late point defense. When the enemy tries to overload one layer, you shift the load to another. That is the real future weapon: adaptability, the ability to change the fight's shape faster than the swarm can re-coordinate. The swarm's most dangerous move is often the re-attack. Not the first wave, the second. The first wave is probing, forcing emissions, spending decoys, learning your reaction rhythm. The second wave is aimed at your pattern, exploiting the gaps it just discovered. If your ship fights the first wave loudly, revealing sensors, firing wildly, exhausting decoys, the second wave arrives to a tired defense with fewer options and weaker confidence. That is why the first wave is not just a defense problem. It is an information problem. What do you reveal? What do you hide? What do you conserve? Doctrine answers with restraint and controlled aggression. You keep some systems quiet. You rotate effects. You avoid using your rarest decoys early, unless necessary. You treat the first wave like a test you must pass without showing the answer key. This is also where layer defense matters, because if you can strike the launch chain between waves, the re-attack becomes smaller, slower, less coherent. The goal is to make the enemy's second punch arrive like a tired swing instead of a knockout attempt. When you hear the phrase "hard kill last," it does not mean hard kill is weak. It means hard kill is precious. It is the last line you want to spend in bulk, because it is the line you cannot refill at sea. The future of hard kill and swarm defense is therefore about efficiency, smarter engagement logic, smarter fusing, cheaper interceptors, and better prioritization. If your system can avoid shooting at decoys, avoid double-tapping harmless tracks, avoid chasing low-confidence targets, you preserve inventory for the contacts that could actually mission kill you. And efficiency is not only technical, it is procedural. Clear rules, clear priorities, rehearsed callouts, disciplined sector ownership. In a swarm fight, hesitation kills, but so does impulsiveness. You want the team moving in a rhythm, not debating, not guessing, not panicking. That is why the future weapon is often training. The ability to run the stack under stress, to switch modes fast, to recognize deception patterns, to keep the truth factory alive. The best ship is not the ship with the fanciest gun. It is the ship that stays calm while the sky tries to make it stupid. Layer defense also includes something that feels unfair, making the enemy's swarm expensive before it flies. That can mean targeting production, targeting storage, targeting logistics, targeting the fuel, batteries, and components that make mass possible. A swarm is only cheap if it is easy to build and easy to launch. If you can force the enemy to hide more, move more, secure more, and replace more, the swarm stops being a bargain. It becomes a burden. This is not a battlefield trick. It is campaign strategy, and it is part of how militaries actually plan to survive a world where drones are everywhere. The trade-off is time and politics. Offensive pressure upstream requires intelligence, access, and often decisions that escalate. You might not always be allowed to strike the source. That is why layered defense is built with options: cyber, EW, deception, kinetic, partnerships, patrols, sanctions, whatever tools the scenario allows. The point is to never accept the swarm as a natural weather event. The swarm is a manufactured storm, and manufactured storms have factories, routes, and switches you can target. If you compress everything we covered into one sentence, it is this: you do not beat swarms by being stronger, you beat swarms by being smarter about constraints. Soft kill first, because it scales, because it attacks coordination, because it creates separation. Hard kill last, because it is finite, because it is expensive, because it should finish what soft kill already weakened. Layer defense, because the best defense is fewer drones launched, fewer drones coordinated, fewer drones arriving on time. The real future weapon is not a single system. It is a stack that turns a synchronized attack into a collection of late, confused, isolated problems. And that stack only works if it stays honest. Lasers have weather limits. Microwaves have range and predictability limits. EW has power and self-interference limits. Decoys can be exhausted. Networks can be jammed. Humans can be overloaded. The enemy knows your limits and designs the swarm to touch all of them at once. Your job is to design the fight so their swarm touches fewer limits at a time. And in the next segments, we can go even deeper into the moments that decide everything. The first minute of confusion, the first misclassified decoy, the first lost track, and the first decision that either preserves tempo or hands it to the attacker. The most underrated future weapon is silence, not the absence of action, but the discipline of controlled emissions. In a swarm fight, every radar pulse, every data link burst, every high-power transmission is a lighthouse that tells the enemy where to aim and what to tune their seekers for. A smart defender learns to see with as little shouting as possible, using passive sensors, off-board scouts, shared tracks, and short directional bursts that give information without giving away the whole orchestra. The goal is to keep your truth factory running while starving the enemy of the clean cues that make a swarm accurate. Silence has trade-offs, because you still need to engage, and engagement requires certainty. So the doctrine is not mute, it is selective. You light up only when it matters, only in the sector that matters, only with the waveform that matters, and you switch patterns so the enemy cannot predict your rhythm. This turns the swarm's job from follow the beacon into solve a puzzle while flying. And puzzles take time, and time is the only thing the defender is trying to buy. Signature management sounds like stealth marketing until you see it as math. The swarm is searching for contrast, a ship against background, heat against cold, RF against quiet. If you reduce contrast, you reduce detection range, and every kilometer you steal from the enemy is minutes you gain for soft kill. Ships do this with shaping, coatings, IR management, and operational tricks, changing course to minimize reflections, using terrain and clutter, masking behind weather, and coordinating so the group presents fewer easy silhouettes. It is not invisibility. It is making the enemy's certainty expensive. The practical effect is that the swarm must spend more drones on scouting and confirmation. That means fewer drones arrive as shooters, or shooters arrive later with lower confidence. This is layered offense hiding inside defense, because you are forcing the enemy to burn resources before the fight even begins. And if they burn resources early, your hard kill inventory lasts longer later, because fewer credible threats demand a missile, and fewer seconds are stolen by uncertainty. A swarm also has a center of gravity, coordination. Even autonomous drones tend to share something: a relay, a timing reference, a planning cue, a leader drone, or a common target update. If you can identify that coordinating element, you do not need to remove every attacker. You need to remove the conductor. This is why counter-swarm doctrine hunts for relays and controllers, the high-altitude drone that keeps everyone synchronized, the emitter that provides mid-course updates, the pattern that reveals where the decisions are being made. Killing or disrupting the conductor turns a chorus into scattered soloists. The challenge is that the enemy will hide the conductor, and sometimes the conductor is not one thing, it is distributed logic. That is why the defense uses behavior analysis, not just shape analysis. Which track is lingering to maintain geometry? Which one is emitting? Which one is holding altitude and position like a floating router? Once identified, soft kill can target it, and hard kill can finish it, because a single high-value kill can reduce the efficiency of dozens of drones in the wave. And that is the kind of exchange rate you need to win. Counter-swarm warfare is also a battle of lanes. The ocean and the sky create natural corridors, approach angles where clutter helps the attacker, and angles where the defender's sensors and shooters are strongest. A good attacker stacks the wave into the weak lane, using geography like cover. A good defender refuses to accept that geometry. Ships maneuver to reshape lanes, to face their best sensors toward the most likely approach, to keep the swarm in a sector where EW and decoys work best, and where point defense has the cleanest arcs. This is not dramatic, but it is decisive, because the same weapons perform like heroes or like fools depending on geometry. The limitation is you cannot always maneuver freely because of mission requirements, escorts, shipping lanes, shallow waters, and threats below the surface. That is why planning and picket assets matter. If you cannot move the ship, you move the warning line. With drones, aircraft, other ships, and passive sensors positioned to see early. Early is leverage. Early is where soft kill breaks coherence instead of arriving too late. And early is where you can decide to avoid the kill box entirely, which is the cleanest victory a defender can get. A swarm can also be countered by making its weapons unreliable. Many drones rely on cheap sensors, cheap actuators, and cheap guidance to stay affordable in mass. That means they can be fragile under the right kind of stress. Heat, vibration, salt spray, electromagnetic noise, rapid maneuver requirements, even minor turbulence can degrade performance. A defender cannot control the weather, but can exploit it, forcing the attack to fly through the worst air, the worst clutter, the worst angles, using decoys and maneuver to make the drones work harder than they were built to work. This is not a guarantee, but in doctrine you do not need guarantees. You need probability shifts. If you can reduce the effective accuracy of the wave by even a small margin, you reduce the number of impacts you must absorb. And when you reduce impacts, you reduce mission kill risk. And when you reduce mission kill risk, your truth factory stays alive. And when your truth factory stays alive, your soft kill and hard kill layers remain coordinated. Swarm defense is a chain, and the chain holds when you keep each link from being overloaded at the same moment. The next evolution is intercepting the swarm with your own swarm, not in a science fiction sense, but in a practical sense. Cheap defensive drones can be launched to extend the ship's reach, to act as pickets, to carry sensors forward, to jam from a distance, or to physically collide with incoming drones at ranges where your guns would otherwise be blind. This is attractive because it shifts the fight outward, and outward is where you have time. It also lets you spend cheap on cheap instead of expensive missiles on disposable targets. The trade-offs are complexity and control. Defensive drones need comms, and comms can be jammed. They need identification logic, and identification can be fooled. They can also create clutter in your own picture if not managed. That is why this layer only works when it is integrated into the truth factory and the emissions discipline, and when it has simple rules: hold a lane, protect a sector, jam a band, break a formation. If you keep it simple, it becomes a scalable buffer that buys time, and time is what turns hard kill from panic into precision. Now we reach the part that makes people uncomfortable: the rules of engagement and the human layer. In many real scenarios, you cannot just fire at everything. There are civilian aircraft, civilian ships, neutral coastlines, political constraints, and identification requirements. That's slow decision-making. A swarm can exploit that by hiding inside traffic, approaching near coastlines, or using ambiguous profiles that force hesitation. This is why soft kill becomes even more important in real war, because it allows you to act without escalating into immediate destruction, to disrupt, to push away, to break coordination while you maintain legal and ethical control. The limitation is that soft kill can also affect civilians. Jamming can spill. Deception can confuse shared airspace. And directed energy has safety considerations. So the doctrine is about bounded effects, narrow beams, narrow sectors, short durations, and strong identification logic. The future weapon is not just hardware. It is policy and procedure that lets you move fast without losing legitimacy. Because in modern conflict, legitimacy is a strategic asset, and swarms are often designed to tempt you into mistakes that are filmed, edited, and weaponized. A swarm's scariest trick is to make you feel like you are out of options, and then punish whichever option you choose. If you go loud, they use it to home in. If you go quiet, they use it to sneak closer. If you shoot early, they exhaust you. If you wait, they compress your timeline. The answer is not a perfect choice. It is a layered rhythm that keeps options open. You start by preserving the picture. Then you apply soft kill to shape the wave. Then you use movement to control lanes. Then you reserve hard kill for the few targets that remain credible, and you keep a reserve for the second wave. This is how you avoid being baited into spending everything in the first minute. Reserves sound boring until you need them. A ship that survives the first wave and then gets mission killed by the second did not lose because it lacked weapons, it lost because it lacked discipline. The future weapon is the ability to fight in chapters, to treat the attack as a campaign of moments, not a single burst of chaos. And the moment you treat it that way, you stop trying to be perfect and start trying to be sustainable. Because sustainability is what wins against an enemy who can launch again tomorrow. Damage control is the hidden layer that turns survival into victory. If a drone gets through, the next question is not just what broke. It is, how fast can we restore function? Can you keep radar cooling? Running? Can you reroute power? Can you patch a cable? Can you switch to a backup aperture? Can you fight through smoke? Swarms often aim for sensors, because sensors are the eyes of the whole stack. If you can recover your eyes quickly, you deny the enemy the snowball effect, where one hit becomes blindness, and blindness becomes more hits. This is where resilience becomes a future weapon. Redundant paths, hardened apertures, spares staged near critical nodes, rapid repair drills, and the mindset that the ship must keep tempo even while wounded. The trade-off is cost and design complexity. But the payoff is massive because resilience changes the enemy's math. A swarm that expects one lucky hit to cripple you must now score multiple precise hits, and multiple precise hits are hard to achieve when soft kill is breaking coordination and hard kill is sweeping the leftovers. If you want the whole doctrine in one mental image, imagine a boxer who never tries to block every punch. Instead, they break the opponent's rhythm. They jam the jab, they make the opponent overreach. They force bad angles, and then they counter when the guard is open. Soft kill is rhythm breaking. Deception is angle control. Emissions discipline is refusing to telegraph. Hard kill is the counterpunch, used when the attacker is off balance. Layered offense is attacking the opponent's legs before the fight starts, so they cannot rush you with full power. Most marketing focuses on the counterpunch because it looks cool. But real survival comes from everything that makes the counterpunch easy. That is why future weapons are often systems, sensors, training, coordination, doctrine, and logistics, because the swarm is a system too. Systems beat systems. And when you accept that, you stop shopping for miracles and start building stacks that are honest about constraints, power, cooling, inventory, weather, human attention, and political limits. Because honesty is how you design something that still works when the sea stops being kind. Now we push toward the finale, the moment of decision. When the swarm is inbound, the ship's job is to keep the attack from becoming one peak. You want to reduce the peak, stretch the window, separate the wave, and remove coordination. Every layer has a job. The Truth Factory builds confidence. Soft kill attacks timing and links. Deception creates wrong aim points. Maneuver shapes lanes. Cooperative defense shares load. Hard kill removes what remains. And layered offense keeps the next wave from being as strong. If every layer does its job, the swarm arrives not as a hammer, but as scattered fragments. The enemy will still try to force a peak, so your doctrine must include a final rule: protect tempo. Tempo is the rate at which you can turn information into action. If tempo stays high, you stay in control. If tempo collapses, you become reactive, and reactive is where swarms feast. So the true future weapon is not a beam or a missile. It is a tempo-preserving machine made of people, procedures, sensors, and effects, designed to keep decisions flowing even when the sky is trying to turn into noise. In the final minutes, you can feel the difference between a defense that is winning and a defense that is drowning. Winning feels like a steady rhythm. Contacts appear, separate, drop off, and the team's language stays clean and short. Drowning feels like stuttered callouts, overlapping chatter, and a screen full of maybes. The point of this episode is that militaries fight swarms by designing for winning rhythm. Soft kill first is how you reduce maybes. Hard kill last is how you avoid drowning in your own spending. Layered offense is how you prevent tomorrow's swarm from being larger than today's, is less than #0. 2 hash is greater than. So when you hear about a new future weapon, the real question is not can it kill drones? The real question is, does it preserve tempo under saturation? Does it scale? Does it work in weather? Does it work when the enemy adapts? Does it integrate into the truth factory? Does it reduce peak load? If the answer is yes, it belongs in the stack. If the answer is no, it might still be useful. But it is not a solution. It is a tool, and tools only win when the stack is coherent. Here is the closing truth. The swarm is not just an air threat, it is an economic and psychological weapon. It tries to make you spend more than you can sustain, and it tries to make you make mistakes on camera. That is why the winning side is the side that refuses to be pulled into a simple exchange. You do not pay missile for drone unless you must. You do not reveal your sensors unless you must. You do not fight on the enemy's preferred timeline unless you must. You shape the fight so the enemy pays in confusion, time, and failed coordination. And you pay in controlled effects and selective hard kills. If you remember one sentence from this episode, let it be this: you do not have to shoot down the swarm to defeat it. You have to make the swarm fail. Fail to find you, fail to coordinate, fail to arrive on time, fail to aim at what matters. And that is what real future weapons do. They create failure upstream, failure in the middle, and failure at the end, so that even if a few drones survive, they survive as isolated leftovers, not as a synchronized hammer. So the finale is not a fireworks show. It is a calm room in CIC where the watch team has kept control of the clock. The best defense looks boring, because boredom means tempo survived. The screen shows fewer credible tracks than the enemy launched, because soft kill turned many into confusion. The hard kill inventory is not empty, because hard kill was used as a finisher, not a first reaction. The ship's radars are still alive, because protection prioritized the eyes and the brain. And somewhere far away, launchers are being hunted, links are being pressured, and the enemy is paying more for each attempt. That is how militaries actually fight swarms. It is not one weapon. It is a doctrine that treats the swarm like a system and attacks the system at multiple points. Soft kill first to break coherence. Hard kill last to conserve the currency you cannot refill. Layer defense to shrink the wave before it forms. If you build that stack, you do not need a miracle to survive. You need consistency, discipline, and integration, because the sea will always hide something, and your job is to make whatever it hides arrive late, confused, and alone. In the end, the future weapon is the ability to stay honest in a world that sells fantasies. Every brochure wants you to believe the next beam will solve everything, but the ocean does not care about brochures. The sky does not care about slogans. What matters is what still works. When the radar picture is messy, the weather is ugly, the enemy is adaptive, and the first wave is only the beginning. That is why this episode keeps returning to the same 3 rules. Soft kill first, hard kill last, layer defense upstream. Because those rules are built from constraints, and constraints do not change just because technology improves. So if you are watching this as a commander, an analyst, or just someone trying to understand the new battlefield, remember the image of the blank night sea. It looks innocent, but it is full of hidden geometry, hidden clutter, and hidden seconds being stolen. The winning side is the side that protects those seconds like treasure, that breaks the swarm's rhythm before it becomes a peak, and that never forgets the simplest truth of modern warfare. You do not win by catching every arrow. You win by making the attack fail, again and again, until the enemy cannot afford the storm.